welcome to our math class here. I've called this one our Finding Factors, and we'll be learning some secrets for how to instantly know whether numbers are divisible by other numbers. So I've dropped a link in the event file and in the comment section here, and you'll find it below. We have a note-taking page that you can see on the screen here, and just a second here, and then there's a practice page that you can use to follow up with that. So give me a like or a comment if you can hear me okay, and if you can see what's on the screen. I'm going to take just a second to make sure that I have everything set up here. Okay, I think we're good to go. Okay, so you should have this Divisibility Rules note-taking page. You can use it to take notes and give some examples as we go through. And then you'll have a practice sheet that you can use at the end. And I'm going to jump in here. So drop a comment or a like if you can hear me okay and see this. And let's get started. So we're talking about secrets of division. Moving on to the final stage here in working with numbers. Okay, sometimes you'll see a big number like 27 or 2,347. So we'll learn to work with all sizes of numbers here. And you'll need to know how to quickly decide if it's evenly divisible by a smaller number, like 2 or 3 or 6 or 9. Okay, those are some examples. But we want to be able to look at numbers and instantly recognize if they can be divided evenly with no leftovers. With numbers up through 10 will give us a really good foundation. Okay, and we'll need to know this when we do long division. And I didn't mean to write factors, I meant fractions. This will be a very helpful skill when you get into fractions. And then when you get into algebra, you'll definitely need this skill. Okay, so today we're going to learn some secrets to solve these mysteries. So this is called finding factors. These numbers that multiply together to equal an answer are called the factors, or you can call it divisibility rules. Okay, so we're going to jump in here and, okay, I got one thumbs up, so I think we're doing good here, that you can hear me. Check if something is divisible by 2. So we'll start off pretty simple. If we take a look at 9, and we've been doing a lot with 10 frames, so I'm keeping the 10 frame theme going here. If we want to see, is that divisible by 2? I'm going to slow down on this example, and then we'll go quickly through the other ones. What does it mean to be evenly divisible by 2? So if we break up 9 into groups of 2s, we have 4 groups of 2s, but there's this one lonely owl left over here. So we would say this is not evenly divisible by 2. So if there's ever any leftovers and you cannot break it up into those even groups, then that does not count as one of our factors. Okay, so we're going to take a look at some numbers, and we're looking for patterns of what works and what doesn't. That way we can make a rule based on our patterns, and then we can apply that to really big numbers, and it will make it seem really easy to do. Okay, so if we look at 4, you can easily break up 4 into 2 groups of 2. Nothing's left over. And 6, you can break that up. Okay, so our rule with 2s is something you might have already known coming into this. If the number is even, then it is evenly divisible by 2. Okay, so you can put that on your note-taking page. If you have an even number, then you automatically know you can divide that number evenly by 2. Okay, let's move on to 3 here. How do we know if something is divisible by 3? And I'm not talking about memorizing every fact of 3 up through 1,000. I just want to look at a number and know, is it possible to divide it by 3? So that we don't waste our time trying to divide something that's not divisible. Okay, so let's take a look at 9 again. If we have 9 things, let's see if we can break it into groups of 3. We'll work with our visual so that we can really understand what we're talking about, and then we'll go into numbers, and I'll speed up as we go through this whole lesson here. So let's see if we find even groups of 3s. So we have 1, 2, 3, 1, 2, 3, 1, 2, 3, there's no leftovers, so 9 is good. Now, we happen to know that you can divide 9 by 3 and you get 3. It works out perfectly. But I want to always start with small numbers that you can see. That way, if you can see something, you'll get a really good understanding of why it works. I think you'll see that through a lot of the classes that we'll be doing here. Okay, this number is, say it if you see it, 11. So we want to see, can we count out groups of 3? We have 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2. We cannot do that. So 11 does not work. And then I'll skip this one. 18 does work if you count out groups of 3s. Okay, now let's just take a look at numbers and use what we know about multiplication and division. And we'll just look at numbers and try to figure out what the pattern is to see what's really going on here. Can you divide 15 by 3? Is there a number that you multiply by 3 to get 15? That's the backwards way of saying it. And at any time, if you know these answers, you can type them in the box or just say it out loud to the screen there. Even if you're watching the replay, by the way, I'd love to see engagement in the replay. So feel free to type answers in the boxes as we're going through here. Okay, 15 is divisible by 3. We can divide it by 5. 21 is divisible by 3. 28 is not divisible by 3. 36 is divisible by 3. And then we have a big number here that we don't know yet. We want to develop a pattern and then apply it and see if we're right. Okay, so let's take a look at all the numbers that worked. 9 works, 18 works, 15, 21, and 36. Now, if you are watching this on the replay, you have the advantage of pausing the video. And I'd love to see if you guys can come up with a secret before I tell you, because this one is a very interesting secret that I never would have known unless somebody told me. But I'd be very interested to hear if anybody can tell what's going on here. So look at those numbers that do work and see if you can figure out what is in common with all of them, besides the fact they're divisible by 3, because that's what we're going for here. Okay, so you can start the video again, or if you're with me live, you can just keep watching here. We have, let's take a look at 15. If you add those two numbers together, you get 1 plus 5 is 6. So you can make a little note of that, or just remember 6. If you add 2 plus 1, you get 3. If you add 3 plus 6, you get 9. Let's go up here. We know 18 worked. 1 plus 8 equals 9. And then 9 works. So every number, and you could do a lot more examples if you wanted to experiment with this, every number that adds to be 3, 6, or 9 will be evenly divisible by 3. Okay, so feel free to try more numbers, see if you can kind of get a handle for how that works. And here is our rule here. You can put this one in your notes. If the digits, those are the numbers inside the numbers here, add to be 3, 6, or 9, then it is evenly divisible by 3. Okay, that's a cool trick that will make it a lot easier. So if we come to our big number here, 1 plus 4 is 5, 5 plus 4 is 9. So since the digits add to 9, that meets our rule. So we know that this number is divisible by 3. And then we can go through the process if we need to of finding out exactly what that is. Okay, let's move on here. I'm going to go through 4 a little bit faster. The way to think about 4 is think about what 4 is. 4 is made up of 2 times 2. So if we can take a number and go backwards, divide it by 2, and then divide it by 2 again, then you know that it's divisible by 4. Okay, so let's take a look at some of our numbers here. We have 8, 11, and 18. I won't take the time to break those up, but we know 8 can be broken in half. You get 4. And then 4 can be broken in half again, and you get 2. So 8 is divisible by 4. Now 11, can you break it in half? You can't because it's odd. So already it's disqualified. Let's try 18. We can break 18 in half and you get 9, but then you can't break 9 in half because it's an odd number, not even. So let's take a look at a few more numbers here. 16, yes. 22 is not divisible by 4. And we're going here just with what we know about smaller numbers to kind of build a pattern of what's going on. 28 is divisible by 4. 30 is not. And let's see, what do we know about 120? Okay, so here's our rule. If the number can be divided by 2 twice, then it is evenly divisible by 4. Okay, and then once you get up into really big numbers and doing that in your head is hard, here's a secondary trick. You can just check if the last 2 digits in your number are divisible by 4. Okay, so let's check here. We can just check the last 2, 20. We know that 20 is divisible by 4, so the whole entire number is. And then if you don't know, just check your last 2 digits. Can you break it in half once and then break that number in half again? Okay, we know 5 probably pretty well by now. As long as there's groups of 5 inside a number, it's evenly divisible by 5. So for the sake of today's class, I'm going to speed through this one and go straight to our rule. If the number ends in 0 or 5, then it is evenly divisible by 5. So you can take a look at those if you want to pause the video and look back on any of that and see where the pattern comes from. But here you can just look at the number 20, for example. And if you can see 5, 10, 15, 20, you have even groups of 5 with nothing left over. So that's where that one comes from. Okay, 6 is another one that's kind of unexpected. So I want to give you guys a chance to try to see what's going on here. So again, if you're watching the replay, you can pause the video at any point and try to find what the pattern is before I jump in and show you the secret right away. Okay, so looking at these, 8 is not divisible by 6 because you have one group of 6 and then 2 owls left over there. 12 is divisible by 6. You have 2 groups of 6. And then 18 is 3 groups of 6. So those are good. Let's look at numbers. 24, we know that if you divide 24 by 6, you get 4, so that's a good one. 30 divided by 6 is 5, so that's a good one. 45 is not divisible by 6. 68 is not divisible by 6. And then 216 is our question. So here is the secret to 6s. If you look at all the numbers that worked, they are all even numbers. And then the other thing is, if you add up the digits, again, 3 plus 0 is 3, 2 plus 4 is 6, 1 plus 2 is 3, 1 plus 8 is 9. You have the exact same situation as we had with our 3s. So it has to be even, and the digits have to add up to 3, 6, or 9. And that makes sense if you think about it, because 6, what is 6 in multiplication? It's 2 times 3. So if you want to divide something by 6, you have to be able to divide it by 2 and by 3. So here's our rule. You can put that in your notes. If the number is divisible by 2 and 3, then it's evenly divisible by 6. Okay, and then, a little bit too fast here, we don't have an easy rule for 7 or 8. So we're going to jump to 9 and 10, and that will be the end of our tricks here, because you often won't need tricks to go beyond 10. Okay, so 9 is another one of our unexpected ones that's really cool if you can, sorry, if you can find the pattern yourself. So if you have a chance, look at these numbers as I'm going over them and see if you can figure out what exactly is going on here. And leave a comment in the comment section below at any point if you want to try to beat me to the punch and say what you think it will be here. Okay, so the only number here that's divisible by 9 is 18. Let's look at what we know about smaller numbers. 24 is not divisible by 9. 27 is. 46 is not. 81 is. And then 216 is our question. Okay, so what's going on with these numbers here? So if we look at each number and add the digits together in the numbers that work, 18 works. 1 plus 8 is 9. In 27, 2 plus 7 is 9. In 81, 8 plus 1 is 9. So this is a much simpler trick here. If the digits add to 9, then the number is evenly divisible by 9. Now, if you get into really big numbers and you add up all the digits, it might equal 18 or 27. So just keep going and get to the point where the digits add up to be 9, and then you'll know it's a good one. If the digits do not add up to 9, then it's not working. Okay, and then 10, I think we all know this one. So I'll go straight through here. If the last digit is 0, then it is evenly divisible by 10. Okay, so let's take a look at some of these numbers, and I'm just going to skip through to number 20, and then we'll look at 4,635. Okay, so if we're looking at 20, let's use our divisibility rules. Start with 2. It is an even number, so we know that it's divisible by 2. So we'll put a 2 there. Then check 3. Do the digits add up to be 3, 6, or 9? They just add up to be 2, so 3 does not work. Let's try 4, so you can follow along with your notes page there. Can you divide it in half and in half again? So 20 divided by 2 is 10. 10 divided by 2 is 5. So that works. You can break it in half 2 times. So 4 is a good one. Then our rule for 5 is the number has to end in 5 or 0. And that works. 6 is already disqualified because we know for 6 it has to be divisible by 2 and by 3. So 6 does not work. We don't have 7, we don't have 8. Our rule for 9 is if it adds up to be 9, and that does not work. And then our rule for 10 is if it ends in 0. So those are the only numbers that those are divisible by, evenly divisible. Okay, I'll skip through 200. And then let's check our big number. So this is where we don't know at a glance, but we don't know what the numbers are when you divide them, but you can tell if it is divisible or not. Okay, so 2 does not work. It's not an even number. Let's check if 3 works. So 4 plus 6 is 10, plus 3 is 13, plus 5 is 18. That's a little too big, so let's take 18 and add those digits. 1 plus 8 is 9. So there you go. It is divisible by 3. It meets those criteria. And when we get to it, we'll know it's divisible by 9 as well, because the digits added up to be 9. Okay, so 4 is not going to work because the last 2 numbers are not divisible by 4. 5 does work because the last digit is 5. 6 does not work because we could not divide it by 2 and 3. We know that 9 works, and then we know 10 does not work because it doesn't end in 0. So there you go. This is not necessarily one of the most fun parts of math. I should have started with that. But it is a very useful skill that will help you excel when it comes to fractions, long division, when you get up into pre-algebra and algebra and you're trying to factor out algebraic expressions. You will use this skill over and over again. So I hope that you learned something helpful here. And I just want to end with this note. A lot of you guys have heard me talk about this before, but I just want to mention it at the end here. This comes from the course that I'm working on, Developing Number Sense Part 2. So Part 2 is almost finished. I'm 1 unit away from wrapping it up. I'm so excited to get that out and into your guys' hands. So the Part 2 course covers everything we learned about number sense, addition, and subtraction using a lot of hands-on strategies. And then it builds on that and goes into multiplication and division. So this is kind of a quick version of 1 unit from that. And I just want to provide you guys with this link and this code here. So if anybody is still interested in purchasing it, it's still available at the pre-launch price for another week or 2 until I put the final touches on it. And you can still use this code. I'm only offering this code to people who are watching the videos or following me on my email. But you can use BTS30 to save 30% even on top of the pre-launch prices. So if you guys are interested in this, I want you to be able to get that best deal on it. And if this is not meeting your need, you're welcome to just keep sticking around in the Facebook group. We will be moving on in this group into more, I would say more fun topics. We have to lay a foundation in the fundamental things like this, but I have some ideas for the next couple videos that we'll be doing in this group. I've mentioned them in my email. We'll be doing carnival games and using probability to create our own games, and I would love to see you guys. We can kind of work together from students all around the world and create our own games and share them with each other and get this worldwide Math for Fun carnival club going on. So I'll have more details coming about that. I also have some ideas for ways to explore fractions, designing our own farms. You'll hear more about that. We might be doing something with quilts. I forget what my other topic was, but anyways, stay tuned on the Facebook page, and I'll have a link below this if you're watching the replay version. You can find a link to access that group. And that's all for today. Leave a comment if you have any questions. Even if you're watching the replay, I'll be following this, and I'm happy to answer any questions as they come. And thank you again for being here on the journey. And I hope that this is helping make math fun, approachable, and understandable for you. All right, have a great day. Give me a minute as I close off here. Okay.